All right, we're looking at calculus, and let me scroll down here. Cal 1, we're doing under integration. We're going to look at the fundamental theorem of calculus. And let me just go ahead and state what that theorem is. Let g be continuous functions. So usually in calculus, most of our functions need to be continuous. In this particular one here, we're on a closed interval between a and b, and g be an antiderivative of g on the interval ab. Then this is true. So let's actually look at some examples of this theorem. So let's go ahead and state, we'll use the same name as our function. We'll go ahead and state, for example, g of x is equal to 8 d, it's not 8 dx, it's just 8, g of x equal to 8, and we are going to be on the interval between 0 and 7. Okay, so let's go ahead and find the integral. So we're going to do 0 to 7, put our g of x in here, which is 8 dx, and go ahead now and evaluate this. So remember that capital G of x is our antiderivative. Capital G of x is the antiderivative. All right. And in other words, we want to do this: g of 7 minus g of 0. And the way we do this is we go ahead and take the integral. So this just becomes 8x, and then we do this vertical line 0 to 7. And so here's what g of 7 is going to be equal to: 8 times 7 minus 8 times 0, which is equal to 7 times 8 is 56, right? Okay. All right, let's look at another example here. I got plenty of examples to look at. Let me go ahead and get that completely out of there. So we have the integral between -1 and 1 of, this time we'll do x squared dx. So we say x cubed over 3, and we're going from -1 to 1. And so this becomes 1/3 minus, we do the upper bound first and then the lower bound, -1 to the 3 over 3. And of course that just becomes 1/3, and because this is raised to the third power, -1 is equal to -1. So this becomes you rewrite this minus sign, and then of course this becomes 1/3 plus 1/3, and that equals to 2/3. I think we got time for maybe one more. We got we're taking the integral from -10 to 0 of 4x plus 1 dx. Of course, I'll be working a lot of these examples, so plus x from -10 to 0. Okay, so if you plug 0 in, you just get 0, and then make sure we put a minus and always start a parentheses here. And 2 goes into 4 2 times, so I'm going to do this: 2 times -10, right, squared, plus -10. And of course that right, so anyway, I'll let you figure that out. -10 squared is 100, so that becomes 200, and 200 minus 10 So this piece here is going to be 2 minus 1. So that looks like that's all going to end up becoming negative 1. And here's the real reason why we want to put a parentheses around this last piece, and that's because of this negative sign. I'm not exactly sure why I'm seeing a minus sign here, as 2 minus 1 is 1, so 1 should go there, not... Well, anyway, if that were a minus, remember you got to distribute that negative. But okay, about made a mistake there. So 2 minus 1 is 2. So our integral is equal to 2. Well, there's a lot of different techniques for solving these integrals, and this is the very basic. We're doing the very basic. The next technique that we'll be using will be called what's called substitution. It won't be in this video, but I believe in the next video we'll be doing substitution, because we're going to get to the point here where we're not going to be able to take the integral here of just the basic technique that we're using here. Now, a lot of times we have to rewrite our integral, and so let's go ahead and do that. 1 to 3 4x to the negative 2 minus 1. It's a lot like when we were taking derivatives. We have to rewrite them before we can actually take the derivative. Now what I'm going to do is go ahead and go through that process. So we add 1 to the exponent, and that makes that a negative 1. And then we want to put that negative 1 down in the denominator, minus, we tack on an x, and of course we're going from 1 to 3. Now remember, if you took the derivative of this, we should get back the integrand. Now let's go through and rewrite this again. This becomes negative 4 over x minus x, and we're going from 1 to 3. So we want to put the do the upper bound first. Oops, so that becomes negative 4 over 3 minus 3 minus, now we want to start a parentheses, it's always minus here, and then we go through and plug our lower bound in like that. Alright, and I'm not going to get caught up in all the arithmetic here. Of course, I've worked these problems out, and so make sure I got the correct answer. But once you get done here, you should get 2/3 as your final answer. So I'll let you do the arithmetic. We just want to focus on the calculus. Even though I know the first semester of calculus for most people is basically a struggle of learning some intermediate algebra, and even sometimes some arithmetic, or more specifically fractions. Everybody has to review back up on your fractions. Well, this time we're going to use a different variable, and for good reason, and that'll become clearer in the next video. Okay, so like in the last one we had to rewrite it. This one here we're going to have to rewrite it several times. First thing I'm going to do is just go ahead, we don't want to skip any steps. U minus 2, let's get this out of radical notation and get it into exponential notation. And then what we're going to do, and I'll just write it over here to the side, we're going to break this up, u over u to the half minus 2 over u to the half du, and if you like, you could put a parentheses around all that. Sometimes it just makes it a whole lot clearer when you do those things. Alright, I want to mention something here real quick. I go back and watch these videos, or the 5 minutes, they're cut up into 5 minute intervals, and actually, you know what? I guess I erased it, but I said something on one of them that wasn't correct. It was back where it was, I think it was 3 minus 1, and I said 2 minus 1, so I meant to say 3 minus 1. I don't go through and edit these videos, and the reason for that is I've got 10,000 hours to upload to YouTube on math videos, and I don't have time to go through and edit stuff out or redo the entire 5 minutes. But I want to make darn sure at the very end that the answer's at least correct. Alright, let's move on here real quick. So we had to rewrite this, and of course we are still rewriting. That's right, I said 10,000 hours. That's a lot of math. But I've got a lot of math to share with everybody in the world, so there you go. 2 times u, and we're going to be bringing that up also, so that becomes negative a half. Let's put a parentheses around this, and du. So we're still rewriting. Want to add our exponents, and so we get u to the half minus 2u to the negative a half. I've listened to myself through a lot of these videos, of course, and there's 2 words I really tried to cut out, but it's just sometimes a habit of saying, and that is the word right and the word so. So I'm doing my best trying not to say neither one of those 2 words, because it just sounds terrible. Where are we? I think this is where we need to be. I believe this is where we need to be right here. Okay, u to the half minus 2u to the negative half. I'm just checking my work. Now we're going to do the integration. So we've got, oh, I said it, didn't I? So we're going to add 1 to the exponent, so that becomes, like I said, it's tough, 3 over 2, and then we're going to put 3 over 2 in the denominator, minus 2 times u. Adding 1 to this becomes just a half over a half, and of course we're going from 1 to 2. I'm going to rewrite this one more time. I think we spent way too much time on this problem. My commentary. U to the 3 halves minus, and then that becomes 4 u to the half. So I've also tried to improve my penmanship. That doesn't seem to be as difficult as eliminating the words so and right. Alright, we want to plug 2 in now, so we have 2 to the 3 halves, 4 times 2 to the half, minus, right, so it's imperative that we put a parentheses here, 2/3 1 to the 3 halves minus 4 times 1 to the half. And I'm going to let you go ahead and work all that out, and I'll just tell you. Now what I'm going to do here is I'm just going to round an answer to 3 decimal places, but if you get something like this at the very end, then you know you've done it correctly. You have done it correctly. I've got an absolute value problem coming up and another one. Alright, so hang in there. We're We're going to work one that involves an absolute value. We're going to go from -1 to 1 of the absolute value of x dx. Let's draw a picture. We will color our graph. We'll give it a purple color, let's say. I'm not exactly sure that's exactly the graph of the absolute value of x, but this is right. I think we're a little too low here, but that's okay. We are going from -1 to +1. And remember, you can think of this as finding the area under the curve. Now this is supposed to be a symmetric picture. In other words, a reflection about the y-axis, but it doesn't look quite that way, but it is. We're going to have to break this up into two separate integrals, going from -1 to 0 and then from 0 to 1. If I were to write this out, and we wanted to write this as a piecewise defined function, we would say, okay, that's supposed to be the absolute value of x. We would, and that's supposed to be a curly bracket anyway. X is, x is, yes, less than 0. X is less than 0. And x is, ooh man, x is greater than or equal to 0. I'm just all over the place here. This defines right here, if we looked at our graph, so the piecewise function, right, defines this absolute value of x. And this is what we're going to be using, this part here. And I think I'll just rewrite this. -1 to 1 of the absolute value of x dx is equal to the integral going from -1 to 0 of -x dx. That would be this top part of the piecewise function, plus, and then we're going to add, going from 0 to 1 of x dx. We had to break up this absolute value function, and hopefully you understand why now. And then we just evaluate each one of these separately. And let's do that. -1 to 0 of -x dx is equal to, hopefully you have caught on at this point, -1 to 0. Right, we add 1 to the exponent and take the exponent and put it down below. Well, we do the upper bound first. We end up with just 0, because plugging 0 in for x, you get 0, minus, make sure you start a parentheses here now, plugging in -1, -1 squared over 2. -1 squared over 2. And this becomes, let's see, 1/2. This is a half, makes it negative, and positive, so that becomes a half. Good enough. And then why would you even do the other part? Go through all that, right? Because you know, because our picture is symmetric, that it should be a half also. dx is equal to, but we'll do it anyway, x squared over 2, going from 0 to 1, plugging it all in, and we get a half. Therefore, we have a half plus a half, and it should all equal 1. You could also look at this geometrically. Well, this is just a right triangle, and to find the area of a right triangle, isn't it a half times the base times the height? So this would be, oh, I said the word so. This would be 1 and 1, and 1 times 1 times a half is a half. So by simply just looking at this geometrically, and then of course the picture is symmetric, so you could just, once you find this, which is a half, right, multiply by 2, and you get the loneliest number. But remember, 2 is just as lonely as 1. Okay, enough of that. Let's work one where you got to kind of memorize the basically the answer of the integral. We're going to go from 1 to e. E is a very special number, and it's not lonely. It's got lots of friends. This is actually, e is approximately 2.71, yada yada yada. All right, Euler's number. That's what e really is. It's Leonhard Euler. That's his his initial and his last name. If you don't know who Leonhard Euler is, you need to look him up. He contributed a lot to mathematics. If you're into programming, check out projecteuler.com, I think it is, or .net, .org. Maybe it's .org, I don't know. If you like to write programs. What do we got? So here's something you're going to have to memorize. That when you see 1 over x, and we're taking the integral of it, it's going to be the natural log of the absolute value of x. It seems like somewhere we did that. I swear, but maybe we did. We go ahead and evaluate it now. The natural log, plugging the upper bound in. And I don't have to write absolute value because he's a positive number, but I'm doing it anyway. I don't know why. Just what's happening. It's what's going on in my brain. The natural log of e, if you remember from 4th grade or 5th grade or whatever grade you did that in, that the natural log of e is 1 minus, and then the natural log of 1 is 0. And we're not going to get into why the natural log of e is 1, but it's pretty easy to figure out, but whatever. And so our answer is 1. Wow, our answer is 1 on this one also. Maybe 1 isn't lonely after all. There's a lot of things equal to 1. Wow. In the next section, we're going to be talking about U substitution. I've got some time here. And what could we talk about? We could talk about this. AB of f of x dx. Could this actually be equal to the negative? This is, there's a lot of theorems I don't state, and it just takes up and confuses people. Theorems do. I did need to state the Fundamental Theorem of Calculus. We flipped. Did you notice we flipped the bounds? We flipped the bounds, and we had to throw a negative out front. Remember what this was equal to. This was equal to f of a minus f of b. And there is sometimes where you need to flip these guys, and just because. So this is equal to f of a minus f of b. What is this equal to? This is equal to f of what's going on here? This is f of b. It's the upper bound minus lower bound. Man, I am always trying to get ahead of myself here. Sorry about that. This is f of b. This is equal to f of b minus f of a, and upper bound minus lower bound. Right. Well, in order for these guys to be equal, if you notice, in order to get this to be equal to this, we're going to have to throw a negative out front. F of a minus f of b. And then when we do that, we could rearrange this as f of b minus f of a. So this is some kind of proof, I guess you could say, leaving out all the math details. Alright. I believe we're going to get into some U substitution.